Who else is trying to get in? Admit all. Let me grab some tissues. All right, you know what? It's 10 o'clock. I want to appreciate your punctuality for being here on time. So let's go ahead and get started, okay? So if you have your notebooks, go ahead and copy today's learning goals. So today we're going to be looking at proportional relationships and we're also going to be graphing them, okay? And similarly, we're also going to be using the constant of proportionality to compare the pace of different animals. So we've talked about this idea of a constant of proportionality, right? A unit ratio, which tells us essentially how fast or how quickly something might be moving. And on Tuesday, we looked at how to find the unit ratio, right, from graphs. And so today we're actually going to put that into effect and we're going to be graphing stuff ourselves, but we're also going to be comparing the rates of different animals. Okay, we're going to be able to decide and explain why something is moving faster than the other. So today's, here's a pencil. Today's vocabulary word is constant. Okay. Yes. Thank you so much for asking. Today is this one. I am posting the link in the chat for everybody. And just a reminder, you can also find this link on Canvas. Beautiful. So, dang, we still get people coming in here. Come on. Class starts at 10, not at 10:03. So, our vocabulary word is constant, okay? So, does anybody know what the word constant means? Like maybe you've heard it in a sentence. Okay, people are still quiet. So, when I constantly tell you to turn in your homework, what does that mean? Keep on doing something, right? If I were to change things up, then it wouldn't be constantly anymore, it would be different. So the word constant actually means to not change. Essentially, it means to stay the same, to not change or to stay the same. And in mathematics, a constant is a number. Oops, I can't even spell constant. I mean, number is a number that doesn't change. It's a number that doesn't change. So if I travel constantly at 20 miles per hour on my bicycle, does that mean it's going to be increasing or decreasing, or does it stay the same if I am constantly driving at 20 miles per hour? Yeah, it means I stay the same, right? It's not changing, right? Part of the definition means to not change. It stays the same. So if I'm traveling at a constant speed of 20 miles per hour, I am constantly staying at 20 miles per hour. Somebody just asked if we need to copy this in our notebooks. Yes, you are copying this vocabulary word in your notebooks. Moving forward. And I'm going to go ahead and put in the chat again the link to the Jamboard. Okay? So we're going to do a notice, a wonder. Okay? We have two graphs here, graph on the left and the graph on the right. Please take 1 minute. Oh, I'm not writing. Ha ha ha. Please take 1 minute. Let me write that first. To write down one thing you notice. Write down in the chat one thing you notice between the graphs, okay? This is easy participation points right here. What is one thing you notice between the two graphs? And when you've noticed something, go ahead and start typing it into the chat, okay? And I'm gonna be copying, pasting some of your responses. And if you private message me your response, I'll go ahead and not put your name. But if you put it publicly, I'll definitely put it out. Okay, thank you, Carla. Thank you, Michael. Thank you, Bricia. How do I take screenshots? I forgot. Huh, I can't take screenshots anymore. That's a fail. Okay, so I see Michael says there's 2 lines on the left and only 1 line on the right. Bricia noticed that they all start at 0. Awesome. That's because they're proportional. Andres notices that they're going in a straight line. Okay. Stephanie notices that there's 2 lines in one graph. Thank you, Fatima. They start at 0. Ooh. Irista noticed that the letters on the left, sorry, the lines on the left have letters. Okay. Okay. So I'm noticing there's 2 lines. They have letters. Let's see, and what else? They start at 0, right? They start at 0. Okay. Um, anything else? Anything else? Maybe what are some of the differences between them? What do you notice a difference between them? So I know we talked about that they have letters. They both start at 0. The one on the right only has 1 line. What else is it missing though? What do you notice from the graph on the left and the graph on the right? What else is it missing? Yeah, the labels. Notice, yeah, thank you. Notice how this graph has labels. Yeah, yeah. The graph on the left has labels. It's talking about the distance on the x-axis, and it's talking about time on the y-axis, but the one on the right doesn't. It doesn't tell you which one's distance and which one's y. So now, some wonders. Please take the next minute to write one thing. What do you wonder? What do you wonder about the graphs? So one thing you wonder about the graphs, and I'll write those down as people are typing them into the chat. Right, so we talked about they have two lines, they have letters, the one on the left has labels. So what does it make you wonder? Thank you, Jade. Thank you, Shayla. Remember, these are just opinions, so there's no like correct answers. Let me write some of these things down though as people are typing them. Did my pencil just die on me? I think it did. Guess I'll have to use my finger. Why only one line? Why no labels? What else? What else? I like that one. Might mean that someone is walking a certain distance and someone is graphing it. Yeah. Someone could be taking their time and distance. Oh, that's a good one. What are the unit rates? Right? What are the unit rates? How fast are they traveling? Right? Is it like 3 meters per second, 6 meters per second? Awesome. Well, all of these things are going to be important for the next part of the lesson. Okay? Let's move forward. So, can I please have, let's see, Italy, can I please have you read, oops, maybe I should move on my iPad as well. Can I please have you read the problem here?
A ladybug and ant move at constant speeds. The diagrams with tick marks show their positions at different times. Each tick mark represents 1 centimeter.
Thank you so much, Italy. Andres, can you tell me one important piece of information that we just read from that problem? What is one important piece of information that we just read?
The ladybug is moving at a constant speed.
Thank you so much, Andres. The insects are moving at a constant speed, so that means it's neither increasing nor decreasing, and they're going at the same speed, whether it's 2 or 3 centimeters per second. Um, there's one other thing that's important from this problem. Let's see, Angel, I know you just got here, but I know you listened to this portion. What is one important piece of information that we're missing here?
Can you repeat that?
I got you. So Andres mentioned that the ant and the ladybug are moving at the same speed or at a constant speed. But there's also one other thing I want to highlight so we remember. What do you think it is from the little from this text here? There's one other important piece of information.
How much speed, like how faster they're moving?
So we're gonna have to figure that out. hmm It's that way. I think somebody. Oh, okay. So somebody wrote that each tick mark represents 1 centimeter. By the way, thank you, Angel. Each tick mark represents 1 centimeter. So if you notice right here, each of these tick marks is 1 centimeter. Okay? So the position here of the ant and the ladybug is 0. They've traveled 0 centimeters in 0 seconds. Okay? What about after 2 seconds? How many centimeters has the ladybug traveled? Bricia, how many centimeters?
Can you repeat that, please?
I got you. How many centimeters has the ladybug traveled? And a reminder, that's how much it's traveled. So how many centimeters has it traveled?
I think it's 9. I can't really tell.
You can't really see? Okay. Okay. Stephanie, do you mind unmuting yourself and letting the class know what you got?
I think it's 4
So can you explain why you think it's 4?
because I counted
What did you count exactly?
from the start and then from like where like the line is.
Yeah. So Stephanie counted right from the start. She counted 1, 2, 3, 4. So that was 4 centimeters in 2 seconds, right? 4 centimeters in 2 seconds. Wonderful. Thank you, Stephanie. Um, let's see, Brian, what about the ant? How far has the ant traveled in 2 seconds? If we start from the start. Okay, moving on. Yeah. Am I having issues on my end? Like, am I lagging or is it like, are you not able to hear me? Because that's like the fifth person to tell me to repeat myself. I don't know if it's like my issues or maybe you're just like getting distracted, but I'll repeat it. So we're trying to find the distance here for the ant. After 2 seconds, how long has it traveled? And remember what Stephanie did. She counted the number of little ticks to figure out what the distance was. Fatima, do you mind unmuting yourself? Ooh, close, Brian. Fatima, do you mind unmuting yourself and letting us know what you got?
6.
And how did you get 6?
Because I counted from the beginning all the way to where the ant is.
Wonderful. Thank you so much, Fatima. So now, okay, we know how much they've traveled in 2 seconds. And I'm not going to tell you, I'm not going to do this for you, okay? I think you can count how many centimeters they've walked in 4 seconds and in 6 seconds. So now let's look at the graph on the right. The x-axis is telling us, sorry, let me use a different color. The x-axis is telling us how far they've traveled, and the y-axis is telling us how long it took them to travel that. One of these lines represent the ladybug, and the other line represents the ant. So I am going to put y'all into breakout groups for 2 minutes, okay? I'm gonna put y'all into breakout groups for 2 minutes. And you need to decide which of these lines is a ladybug? And which of these lines is the ant? Now I'm trying to bring up the participants list here. Let's see, there's 26 of us, so okay. We have some groups right now, just making sure that, let's see. Kevin, I'm gonna put you in room 7. So please make sure you turn on your microphone so you type into the chat. Okay, I'm gonna randomly call on a group to share out their responses. So it is important that you at least have an answer and an explanation, okay? And I will give you a hint. Think about how fast they're traveling and then look at the graph and see which one would make more sense, okay? 2 minutes in your rooms. We'll come back. Miguel, Darelli, and Kevin, if you could please join your groups. Your partners are waiting for you. Darelli, are you there? Okay, there we go. All right, welcome back, everybody. I see people are still coming in, they're settling in. Is that everybody? That is everybody. Awesome. So I'm just gonna call a random number, okay? I'm thinking of a random number. Okay, group 5, that is Ana and Andres. Can I please have one of you tell me, what do you think you is? Is that the ladybug or is that the ant?
For you, I think it's the ant since it's going upper, which is faster.
Okay. And so does that mean that V would be the sorry, I wrote that wrong. No, 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 that was correct. I want to keep colors consistent. So you think this is the ant and you think this is the ladybug, correct?
Yes.
Okay. Um, is there anybody that agrees or disagrees with Andres and Ana? Or did anybody else have an opposite answer? Okay, Michael's team agrees. Okay, so I do agree that the steeper the line is, in theory, the faster or the bigger the slope should be. Absolutely. Andres, can you actually tell me how fast the ladybug is traveling? If we know that it travels 4 centimeters in 2 seconds, what's the unit rate there? Andres?
Yes.
I had asked you, if we know that the ladybug is traveling 4 centimeters in 2 seconds, how much is that per second? What is our unit rate?
1 for 2.
Yeah, 1 second means 2 centimeters. Thank you so much. 2 centimeters in 1 second. Now, Michael, same logic. How fast is the ant traveling per second?
I don't know, 6 maybe?
So remember, it's 6 centimeters, right? I marked it down here. It's 6 centimeters in 2 seconds. So how much is that per second? Does anybody think they know how fast they travel? Sorry. Okay. Shayla, do you mind unmuting yourself and saying your answer?
I think they travel 3 centimeters per 1 second.
And how did you get 3 centimeters per 1 second?
I see that 3 plus 3 is 6, so like I just put it into 2, and
Okay.
then 2 seconds. So yeah.
Beautiful. Thank you so much. Is there another way we could have gotten 3 centimeters per second using the numbers 6 and 2, maybe? Do y'all remember what we were doing on Monday? All those scenarios, all those situations, what did we do with the 2 quantities? What operation were we doing? Hmm. We were dividing. Yeah, we were dividing. So another thing we could do instead of like trying to think of like what number plus one number equals 6 is dividing. So Michael, do you feel comfortable enough to explain how we got 3 centimeters? Okay, so now that we know how fast these insects are traveling, let's look at the graphs again. So if this is the time on the y-axis, this little tick mark right here at the bottom, how many seconds is that? There's 24 of you. I think somebody has an answer. Okay, I guess I'll just call on people then. Hairista, what do you think, how many seconds do you think this little line represents?
Which line?
The one I drew down here. Right, so there's 1, 2, 3, 4, 5, 6 of these. So how much do you think one of these represents?
1 second.
1 second. Thank you. Oopsie, I deleted that. So this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, and 6 seconds. Now, if we look at the x-axis, and a reminder, the x-axis represents how far they've traveled. This point right here, what number do you think this is right here? Let's see. Saul, I haven't heard from you in a while. What number do you think this represents right here, this quantity?
Can you repeat that again?
Absolutely. So what number do you think this quantity represents, or like what number should go right here?
1 centimeter.
1 centimeter. So these 2 blocks equals 1 centimeter.
To be honest, I really don't know.
Okay. Well, how many blocks do you see?
6. Well, I
Like,
mean 2.
yeah, 2. So what number do you think this is? How many boxes do you see?
2.
2. So what number do you think this is?
1. Or I don't know, dude.
You're,
I'm really confused right now.
the answer is literally what you're telling me. So how many boxes do you see?
2.
Okay. And what do you think this number should be then?
2.
Absolutely. See, you have the answer. You were just confusing yourself. Thank you, Saul. So this number right here is 2. What about this next one right here? Let's see. Jade. What number do you think this is right here? The next one over. Is it lagging on the screen? Because it honestly feels like y'all are not even looking at the screen. Am I even screen sharing? Yeah, I am. This one right here. The one right after. What number do you think this is? Yeah, it's 3. I mean, there's 3 boxes. So it makes sense that it would be 3. Awesome. So it's like 3 centimeters, right? So like 1 centimeter, 2 centimeters, 3 centimeters, 4, 5. I'm not going to label everything else. So according to line U, this bug traveled 2 centimeters in 1 second. Which bug traveled 2 centimeters per second? Was it the ladybug or the ant?
Ladybug.
The ladybug, right? Thank you so much. So in fact, it's not the ant, even though it looks like it is steeper, and I do appreciate Andres for saying that it's steeper, so it must be traveling faster. It's not always the case that that's going to be true. You have to look at your units. You have to look here. So the ladybug is actually this one because it traveled 2 centimeters in 1 second. So what about V? Which insect is V?
The ant.
The ant. It's the ant. And can somebody explain to me why it's the ant? Somebody who wants to push themselves in their explanations? Let's see. Enrica, I haven't heard from you in a bit. Why is V the ant? Because it traveled 12 distances in 4 seconds. Oh, so you looked at the graph over here and you saw that it had traveled 12, and then you made the connection that over here at 4 seconds, it would have traveled 12 centimeters. Yeah, I mean, it's true, right? It's traveling 3 centimeters per second, so it makes sense that the ant would be that one. What's the unit rate? How fast is the ant traveling per second, Jenny Salas? Let's see, Miguel, how fast was the ant traveling per second? Okay, for the sake of time, we are gonna move forward, but if you notice on the graph, just like we did it with the ladybug, at 1 second, it traveled 3 centimeters. And so the speed is 3 centimeters per second. Miguel, we cannot hear your microphone, okay? So I'm really hoping that you are being attentive, that you are writing this down. If you're simply just turning on the computer and turning on this show, you're not gonna get anything out of it, okay? So I'm hoping that you are participating and like answering the questions, even if you're wrong, okay? And I do want to applaud and appreciate those who are. So again, we're going to look at the same scenario. Just a reminder, the ladybug is the U, V is the ant, and we know that the ant is traveling at 3 centimeters per second, and the ladybug is traveling at 2 centimeters per second, okay? So how long does it take for the ladybug to travel 12 centimeters? And similarly, how long does it take for the ant to travel 12 centimeters? In the chat box, go ahead and let me know how long does it take for them to travel those distances. And the number here we're looking at is 12 centimeters. How long does it take for them to travel that long? And when you have an answer, you're more than free to type it into the chat, okay? Okay, okay, I'm starting to get some answers. And I want to hear the explanation, so I am going to ask people to unmute themselves, okay? Let's see, who have I not heard from? Cristiano, how long do you think it's going to take the ladybug to travel 12 centimeters? And just to give you a heads up, it's traveling at 2 centimeters per second. So how many seconds do you think it's going to take for the ladybug to travel 12 centimeters? Jenny Sales, do you mind unmuting yourself and explaining to the class how you got your answer? By the way, it's correct. That's why I want you to explain your answer. Six seconds because 2 times 6 is 12. Okay. Okay, so let me write that down with units so the other students in the class can see. So we want to know how long it takes for it to travel 12 centimeters. And if we know that it's traveling at 2 centimeters per 1 second, we know that we can just multiply it by 6, right? Because 6 times 2 is 12. Absolutely. 6 seconds for the ladybug. Andres, similarly, can you go ahead and unmute yourself and let us know what you got for the ant, how long it takes for them to travel 12 centimeters?
Can you repeat that again?
Absolutely. So how long does it take for the ant to travel 12 centimeters, and how did you get it?
Next to the 4 seconds because it took it took 2 seconds to get to 6 centimeters. So
Okay.
that was just my guess.
Okay. So what Andres realized was 2 seconds is 6 centimeters. So if it travels at the same speed, right, at a constant speed, then it must be the case that 4 seconds would be 12 centimeters. Thank you so much, Andres, for unmuting yourself and explaining your thoughts to the class. Another way we could have done this is, since we know that the ant is traveling at 3 centimeters per second, Jenny multiplied, but we could also divide. We could have also done 12 divided by 3, right? Because it's traveling at 3 centimeters per second. That's okay, Andres. Thank you for letting me know. And that would give you 4 seconds. Okay? Are there any questions or concerns about these ratios? Right, so we're comparing the speeds of the bugs, we're looking at the graphs, we're looking at number lines, and we're talking about rates of speed, okay? And just a reminder, right? The ladybug is traveling at 2 centimeters per second, and the ant is traveling at 3 centimeters per second. So for this particular problem, it's asking us, oops, I just did that. This particular problem is asking us to scale the vertical and horizontal axes by leveling each grid line with a number. We already did this earlier, okay? How much was, oops, I didn't want to do that. How much was each line right here? How many seconds was each of these lines that I just drew on the board? Belinda, how many seconds was each line?
Five.
Each of these was 5 seconds. So this was like 5, 10, 15, 20, 25, 30. Is that what we did? Oh, I just realized there's a chat box. It's supposed, yeah. It's supposed to be 1, right? From the very first problem we did, okay, Belinda? I don't know, maybe that got cut off or you weren't able to see on your screen, but we decided that each of these is 1 second. And what about on the x-axis? Let's see, who was it? There was somebody I was calling on. Saul, how much each of these little boxes is worth? Can you remind me again how much each box was? On
A
the bottom.
centimeter.
1 centimeter, right? Thank you so much. So each of these was 1 centimeter. And it's really important that when you have a graph, not only do you have this labeled, right? So you know what it's talking about, but you also have the numbers because you need to know, well, you know, how much does each little box measure? So those are the important things of graphing. You need to have your labels for the X and the Y axis. So this is a pretty open-ended question, right? Why is it important to have the X and the Y axis labeled? Why is it important to have units. I'm going to give you 1 minute to, in the chat box, just write out why you think it's important. And again, this is free participation points. So why is it important to have the X and the Y axes labeled? Thank you, Enrica, for typing out your opinion. Thank you, Jade. Absolutely. Some of the people I've mentioned, so we don't mix up the numbers. Yeah. Oops. So we don't mix up the numbers, right? You need to have the labels to make graphing easier. So you don't get confused. Yeah, I mean, you want it to be organized. Absolutely. And you know where it starts. Yeah, so you know where it starts. All of these are important things to have your axes labeled. And I appreciate those of you typing in your thoughts and opinions into the chat. Last one before our exit ticket. So take a look at this graph right here. It's a graph of the Krusty Krab. Is it labeled correctly? Why or why not? And if it's missing stuff, type into the chat, what is it missing, or what's wrong? Or if it's not, just type in it's correct. Thank you, Shayla. Thank you, Anna. Thank you, Bricia. So I really want to highlight what some people have said. It's missing the labels, right? It's we don't know which one's the X and we don't know which one's the Y. We don't know what the side represents. And there's one other thing. Look at the numbers. What do you think is wrong with one of the axes? Yeah. Yeah. It's the numbers are messed up. Look at the y-axis. Usually the smaller number is supposed to be on the bottom, like 100, 200, 300, but look, it's the other way around. Yeah, good eye on that one. Yeah, so this one's missing a lot of things, right? It's missing the labels, the X and the Y axes. We don't even know what it represents. And it's also labeled incorrectly. So what I'm gonna do now is I'm gonna provide with you the exit ticket, okay? This exit ticket is to see whether you're understanding this idea of reading graphs and interpreting them. A reminder that on Tuesday we practice interpreting graphs, right? That's where you found the X and the Y and then explained what it represented. Use that same skill on the exit ticket. You know how to read the graph and you know how to find a unit rate. So you could totally you could totally answer the exit ticket. Please be sure to log in through Canvas and work on this exit ticket. And when you are finished with the exit ticket, feel free to call it a day. Have a good one. Yeah, you have a good one. Thank you, Jade. You're more than welcome to go ahead and take a break, okay? Have a good one before it starts getting cold and rainy. Just a reminder for everybody, there are office hours today right after class, not this class, but the next class. Have a good one. All right, y'all. I know there's only a couple of you left. Just a reminder that we do have office hours today after the next class. So if you would like some assistance on just understanding concepts better or like IXL skills help, feel free to drop by, okay? From 12:30 to 1:30. Y'all stay safe, all right?